All right, dude, we are live. What's up, guys? This is Dem Keys, and today we are going to be learning about magic commands in Jupyter Notebooks. So I had to do a bit of research to kind of get started with this, and so far I have like sort of an understanding. Like I had to go just for the sake of my curiosity. I had to go back to the basics and well, not really back to the basics, but understanding what exactly is going on. Sorry if you're hearing popping. I'm just doing that with my. Oh, great. Now that I'm trying to do it, it's not happening. I'm doing the knuckle popping, finger popping, whatever. Okay, so um, I wanted to understand how. Well, I wanted to learn about magic commands in Jupyter Notebooks, and then that kind of I'm missing the word here, but that kind of uh, I don't know, piqued my curiosity about how exactly Jupyter Notebooks is working in VS Code. But that's like a separate thing. We don't need to discuss that. I did my research with Gemini, and dude, I'm glad that we are now able to just ask these questions to an LLM and get the answer from it. Like it is super convenient. It's great. It's awesome. So yeah, okay, doing that research, I found out about magic commands in Jupyter Notebooks. And actually, okay, so I had seen magic commands being mentioned on and off here and there. I just never really understood the idea behind them, the concept behind them. And today I did research and finally understood what's going on. And it's, dude, it is super convenient. So, okay, the way that I got to this point was, hold on, before, like, right before I started the stream, there was something that I needed to remember to write down because I wanted to do that. I wanted to look into it or something. Actually, real quick, let me just, oh, you know what? I'm going to say some stuff. Check, check, testing, testing, 1, 2, 1, 2. And now I'm going to mute my mic and then I'm going to unmute the stream so that I can hear the stream on my end and it doesn't come through on the mic. Okay, check, check, testing, testing, 1, 2, 1, 2. Check, check, testing, testing. Okay. Okay, cool. We are good. I just wanted to make sure that the audio levels were good and yeah, the audio seems good. Like the music seems it seems good. But also, I don't think I need to worry about that too much now. Well, I mean, I kind of still need to worry about it for, the live portion of the stream, but for the VOD portion of the stream, I don't need to worry about that because the music just doesn't come through in the VOD, so, that's convenient. Okay, back to what I was talking about. So this whole thing, actually, okay, I was trying to remember, what was I trying to remember? Last thing I remember was that I needed to, cuz like I want to work on a VJing program. I don't know if there's a better term, but like VJing, basically it's doing visual effects to music. And there's a couple of people on Twitch as well who do it and my god, they do an amazing job. One very good example that I can give is a person named Socks VR. She was actually the first person that I had seen. I'm not saying that she did it first, but like she was the first person that I found doing this. I'm sure there were other people that were doing it as well. But she was the first person that I had found doing this, and yo, she does an amazing job. Let me just look up her thing so I can. Okay, so her Twitch is SOKKZVR, Socks VR. Go check her out. She does just amazing visual effects. It's a if you're into live visual effects, you're gonna have a good time there. So yeah, okay. I wanted to create my own VJing program. There are other programs that are available, but I kind of wanted to start from scratch. I kind of wanted to build my own from scratch because I don't know. There's something appealing about building that kind of thing, and yeah, I kind of want to build my own tool set, my own tool kit for doing VJing stuff, and I think I'm also gonna make it open source. Like, I mean, okay, to be fair, what I'm building is not. It's not going to be anything special. It's not going to be anything big and flashy. It's going to be at best very basic VFX, but it's still something. And I mean, that's, where I'm starting because I don't know how to build VJing programs. So that's what I'm starting with. I'm going to start from scratch, and then uh, I'm going to do it practically and see what features I need to add, and then add the features accordingly. And I also need to Dude, I need to work more on my VTubing app. Like, I haven't done a whole lot of work on the VTubing app for a while. I haven't done a whole lot of work on my VTubing model either. There's stuff that I wanted to add to it that I just never added. Something that I want to try adding. So, okay, I worked on audio reactive stuff for my uh I worked on my own audio reactive system, but I also want to try using LASP, which is it's a plugin for, how do I say this? Oh yeah, okay. So LASP stands for I think it's low latency audio signal processing. So basically, you can do signal processing with it, or it does the signal processing for you and presents the data in a certain way to you. So you can then take that data and apply it to various types of effects. It also has, like, in order to be able to apply those values to various things, it has like property binders that you can set up, either through the inspector or even via code if you want. I haven't tried the via code part, but I'm pretty sure there is a way to set it up via code as well if you want to. So I kind of want to import that into my main VTubing app, my main VTubing project, and use that instead of my own, like what I'm using right now. Because I mean, building my own thing from scratch was fun, but I feel like I'm ready to start using LASP. Also, I'm gonna be using LASP for my. I don't know why my voice is shaking. Hold on, dude. Give me a second. Let me just. Okay, so I'm watching Lena Lazar's stream in the background. I feel like my voice is shaking because I'm not able to hear the other background sound that I'm trying to hear or that I'm trying to have. I don't know. Okay, actually, let me load up somebody else's stream. This is basically just for my own stimulation. Oh God, music! Stop! Mute this. Okay, all right, sure. So, what was I saying? Yeah, for some reason my voice randomly just starts shaking. Um, yeah, I plan on using LASP for my VJing program as well. It's gonna be the base thing that does the actual signal processing, the audio signal processing, and then from there it's going to be fed into various systems that use the signal in different ways. And recently I've been messing around with LASP, and I've kind of gotten comfortable with it. It's great. It's amazing. It's for anyone who's interested in checking it out. Give me a second. So we're gonna do this, and then Unity LASP. All right, open that up and go back. Okay, cool. So this is LASP. This is low latency audio signal processing. Basically, you just need to install this, and then you have your audio reactive thing. This thing is going to give you the signal. There's various filters that can be applied. I haven't looked into how customizable it is in terms of, like for example, if I want to, so okay, it gives you four options for bands. You have, I forgot what one of them was, but then there's also band pass, which I need to look into what that does, and then there's low pass and high pass. um I believe low pass only allows low uh lower frequency stuff to get through, and high pass only allows higher frequency stuff to get through. Or I think I've got it the other way. I think I've got it the other way around. Give me a second. Let me just look this up, because I always mix them up. What is low pass filter? A low pass filter is a filter that will pass low frequency signals but block high frequency. Yeah, okay. So low pass only allows lower frequencies from the spectrum to get through, and high pass only allows, or mostly only allows, high frequencies on the spectrum to get through. I need to look into what bandpass is. I'm still not entirely sure about that. Also, it presents the data to you in various other ways as well, so you can do your own processing if you want. So I'm going to look into that as well, creating my own little system of. I need to look into how to do it in a more performant way. But for the time being, I want to use what this plugin is providing to build. I want to use the base features that this plugin provides to sort of build my system. I want to focus more on building the system rather than building rather than trying to add features to this plugin, because I already have like a base set of features for signals, and it seems to be decent enough to get started. I'm gonna have to see to what extent, like maybe I need to add something to it later on. I can add it. It does present the data to you in various other ways that you can then use for other purposes. But for the time being, what I'm planning on using, the first thing I plan on using is, hold on. The first thing that I'm already using is this, the audio level tracker component. So this thing, it gets the audio and it does the processing, and then it presents that data to you. And then on the same game object, you can attach a property binder, and you can add various, or well, actually no, I think, hold on. the property binder, I believe it's already, I don't remember. I don't remember. I think the property binder is like a separate component or it's part of the audio level tracker. I think it might be part of the audio level tracker component itself. But either way, you can create properties or property binders, and then you can set targets for them and control various properties using that. You can also do this. You're not limited to just game objects and their components. You can also do it for scripts. So in a script, it has to be a property though. It can't be a field. This is something that I've noticed. It has to be a property. So even if it's a script that you are going to attach to a game object, you need to make the variable a property. And then that property is going to be accessible, or it can be controlled through the property binder. So I plan on using that. There's basically through audio level tracker, there's a fair bit of stuff that I can do, and I want to do as much as I can with it before I start trying to do custom processing stuff. Because for now, I want to focus on building the system itself, because there's quite a bit of work to do there. But yeah, I'm excited for that. Okay, so we were supposed to be looking into magic commands. So I found out that you are able to in your Jupyter notebook, within the cells, you are able to provide something called magic commands. They can be either line magic or cell magic. Line magic is, it basically applies, and this is so far my understanding. We're going to read through this whole thing to get a better understanding of it. But yeah, my understanding is line magic only applies to like that specific line, and cell magic applies to the entire cell. Funny enough, this whole thing started when I was doing research on how to benchmark Python code, and somehow it didn't occur to me that let me show you. Okay, I restarted VS Code earlier, so I don't know if I'm going to need to do something. I think the environment is already active, but let's see. Print hello world. All right, so give that a second because it's the first run since I restarted VS Code. Give that a couple of seconds. Basically, once this cell runs, or well, when any cell runs, a timer or a time, not a timer, a time gets displayed. I think down here or over here, there'll be a green tick and a time, and that time is pretty much how long the cell took to execute. So somehow it didn't occur to me that I could use this to benchmark the code, because I'm not looking to get an average. I'm looking to just run the code once and see how long it takes to execute. Fortunately, there's also another thing. It's called time it, which is one of the magic commands that you can use. Apparently, it runs the cell a couple of times, or it runs that code a bunch of times, and then it gets the average of the runtime, and that is your result. It didn't occur to me to get an average, though. Okay, getting an average, it seems like a better idea than just getting the runtime once, because you don't know what the situation is with the system at that specific time when you're running the code. Like something might cause the thing to run slow or run faster, or there might be like a difference in seconds between different cell, or well, between the different times that you run this cell. So or the different iterations of running this cell, there might be like a second or two's difference. So getting an average will give you a better idea of what the actual runtime is. So yeah, this is the time that I'm talking about. So I wanted to test because I was looking into other alternatives for pandas, and one very famous alternative that popped up is something called polars. This is it's also it's something similar to pandas, but it works in its own way. It has its own way of working. It has its own API, and apparently, according to a lot of people, it tends to be faster in quite a few situations. It tends to be faster. It has like a simpler API for doing stuff. People have been praising this library a lot, so I was looking into it, and then that got me wondering, how can I speed up pandas? I'm still sticking with pandas. I'll explore polars a little bit later, at a future time when I get the chance. But for now, I'm sticking with pandas. I wanted to see what I can do to speed up pandas, because the speed up becomes necessary when you start working with bigger data sets, like more massive data sets. It becomes important to speed up wherever you can, right? And there are some opportunities to speed it up. So I wanted to explore those possibilities. And that's what got me thinking about, okay, maybe I should look into how I can benchmark the code. And there's ways to benchmark the code outside of Jupyter Notebook. But because I am using Jupyter Notebooks, I was like, okay, let's just use this, because anyways it's giving a runtime, right? It's okay. So this is the, you know what? Let's do this. Let's say a equals 5 for I in range, I don't know, 750,000, or let's say 75,000. A plus equals 5. A multiply equals 2. A, I don't know, plus equals 2. And that's it. So let's try running this. Okay, so this took 1 second to run. Let's make it 750,000. All right, so you can see it's taking a couple of seconds to run, right? You know what'll be interesting? Actually, no, I don't want to do this, because this is taking, oh wow. Okay, this is now taking 20 seconds. Okay. It is still going. I can interrupt the thing if I want, but I'm just going to let it finish. Wait, 75,000 took 1 second. 750,000, should that take 10 seconds or 100 seconds? Either way, I'm looking into, we are looking into magic commands today. Oh God, this is still running. 1 minute. Okay, it's done. Great. Awesome. So let's take this down to 750,000, and now let's add a cell magic command, time it. So the way to do that is this, and then it gives you a list of the magic commands that are available to you. So a single modulo operator is a line magic, and double is a cell magic. We're gonna be exploring both of these. Okay, time it. Great. So we're going to run this. This is going to run for a couple of iterations, and then it'll give some information. I only realized that this runs for a couple of iterations because I did I did print hello world. For some reason that wasn't coming out. I did print hello world, and I did a time it above it, and it printed for a while. Okay, so what does this say? Mean standard deviation of 7 runs, 100 loops each. Wait, so it ran the thing in 100 loops and then did 7 runs of those 100 loops, and then it got the average of that. I need to look into what this sign is. It says plus minus. I'm not sure what this means. I'm also okay. This says microseconds. No, this says milliseconds. I think this is micro or nanoseconds. So that's that many nanoseconds per loop. And this is, I think, 12.7 milliseconds per run. Hold on. Let me look up this. What is the plus minus sign? The plus minus sign, or plus or minus sign, is a symbol with multiple meanings. In mathematics, it generally indicates choice of exactly 2 possible values, one of which is obtained through addition, and the other through subtraction. I don't get it. Hold on. Plus minus symbol stats. The use of plus minus for an approximation is most commonly encountered in, okay, you know what? I can read that here. Give me a second. All right. Transition back. Okay, in statistics and experimental sciences, the sign commonly indicates the confidence interval or uncertainty bounding a range of possible errors. Sarah, welcome to the stream. Hello, hello. How's it going? It's been a while. How are you doing? I'm okay. I'm okay. How are things with you? How have you been? We are looking into magic commands in Jupyter Notebooks today. You're okay? Hell yeah. Good to know. Good to know. We are currently looking into plus minus sign, and I'm trying to understand exactly what this means in the context of statistics. Yeah, magic commands are something that you can use with Jupyter Notebooks, which are these things. So basically, you can create these notebooks, and in the notebook, uh, think of this one tab as a notebook. In this notebook, you can create cells, and in those cells, you can type in commands. And so then when you have multiple cells, you have these multiple blocks of code that you can execute independently. You can execute each of them whenever you want. And magic commands allow you to enter commands into those cells. These are commands that do certain things that aren't necessarily part of the code that you are writing here. So in this case, for example, time it can be used to time actually not just one execution, but multiple executions. It runs the same cell multiple times, and it gives you sort of an average of how long the thing takes to run. But there's a couple of other magic commands as well. By the way, in the next like 30 seconds, there's going to be an ad playing. So what I'm going to do is I'm going to start the ad timer, not the ad timer. I'm going to start a 30-second ad right now, and I'll take a little hydration break. So I'll see you guys in 30 seconds. All right, welcome back. Let me just change my layout a tiny bit. Okay, we can do that, and we can do this, and we are good. All right, cool. Okay, so we were looking into the plus minus sign. I don't fully understand what it's doing in stats. In statistics and experimental sciences, the science no, the sign commonly indicates the confidence interval or uncertainty bounding a range of possible errors in a measurement. Okay, how would I even explain that? Like, okay, so often so it says that the confidence interval or uncertainty bounding a range of oh wow, I totally forgot you had emotes. Yeah, I do. Not too many though. Um I have like two or three. I haven't really done a whole lot in terms of doing emotes. But yeah, yeah. Three? Okay. Wait, what was the third one? Let me look at my because I remember two. One is the heart thing, the other is a peace symbol, and the other is let me look at my own. Oh, just a laughing thing. Okay. So, um often the standard deviation or standard error. The sign may also represent an inclusive range of values that a reading might have. You know what? Here's what I'm gonna do. I am gonna go and ask Gemini because I feel like I'm gonna end up digging for answers quite a bit. Um, okay. I ran uh I ran time it on one of my cells and I got the following results. Hold on. Let me bring up this thing. So it says 12.7 milliseconds plus minus 718 uh microseconds. I'm not sure how to add the microseconds thing. Per loop, mean plus minus standard deviation of 7 runs, 100 loops each. I'm having trouble understanding what any of this means. So let's see what Gemini says. I'd be glad to break down the results you obtained with so and so. 12.7 milliseconds. This is the average execution time of the code within your cell. It stands for milliseconds. So on average, your code took 12.7 milliseconds to run. Plus equals 718 microseconds. Oh, I thought that's nanoseconds. Okay. Microseconds. This is the standard deviation. Oh, okay. Somehow it didn't occur to me that like this thing here was representing this, because it does say mean. Mean is the average, basically. So if this is giving the average, yeah, that's basically, yeah, Sarah, that's basically the heart emote. And the binary digits. Hold on, let me see what my thing is. Wait, hold on. I need to look at the thing. Where is it? Here it is. Okay. So let me look at like a bigger version of this. Oh yeah, I think it just says LUV. Yeah, I think it just says, if I remember right, the binary says LUV. They're ASCII characters, basically. So if you convert the binary to integers, you'll get the ASCII encoding values, and basically you can then convert that, and it says LUV. Okay, okay. So back to reading this. This is the standard deviation of the execution times. It indicates how much of the individual execution times it indicates how much the individual execution times varied from the average. How much they varied from the average. So wait, okay, I've forgotten what standard deviation was, but apparently standard deviation is just how much it deviates from the mean. How different it is from the mean. This is giving the difference. It indicates how much individual execution times varied from the average. A smaller standard deviation means the times were more consistent, and the US stands for microseconds. Okay, so this is a standard deviation of 7 runs with 100 loops each. So it ran this cell in, wait, let's read this. So it says per loop. This specifies this specifies that the timings were measured for each iteration of the code within your cell. Wait, back up. This specifies that the timings were measured for each iteration of the code within your cell. If you had a loop in your code, this would indicate the time taken for one pass through. Oh, this would indicate the time taken for one pass through the loop. Hold up. So what if I run this? What if I change this to 5? Let's see how long that takes. Okay, it's still 7 runs. Okay. I thought like my number of iterations had something to do with it, but no, it doesn't. But it says here that if you had a loop in your code, this would indicate the time taken for one pass through the loop. Oh, this as in this. So it takes roughly, but no, this is supposed to be the standard deviation. So the standard deviation is telling us how long one iteration of the for loop took. Like, is that what's going on? Let's run this again. Right. So we have 763 microseconds per loop. Wait, did it mention per loop previously? Oh shit, I didn't notice that. It says per loop. Though, is it one of my loops or is it because this thing is already looping, right? What if I just do this? Let's see what that looks like. It still says per loops and now it's saying nanoseconds. That's interesting. So if you had a loop in your code, this would indicate the time taken for one pass. Okay, so I'm a little bit confused about that because the thing itself seems to be looping. So is it telling me about the runtime? Is it telling me how long one iteration of my loop took or how long one iteration of its own loop took? Oh wow, holy shit. Wait, this is 1 million loops each? That's crazy. That is crazy because there's hold on, that's kind of interesting. So when I give it a certain amount of it kind of seems like when I'm overloading this, it reduces the number of loops. I don't know if it's just like an arbitrary amount of loops or okay, so here it's 100, right? And now I have this for loop that's running 7,500 times. Okay, still 100. What if I have two for loops that run 7,500 times? What happens then? Let's see. Okay, so this is going to take a oh, that's interesting. I thought it's going to take a little longer to execute, but no, it didn't. Okay, let's try running this. Okay, so when I increase the number of loops, I mean, just now it didn't reduce the number of just now it didn't reduce the number of loops here, but like previously it reduced it down from 100 to 10. What if I just do this? Okay, it's still 100. I was trying to experiment with different things to sort of overload it. But this is interesting, dude. So if I do that, it runs for 1 million loops and then it gets the average of all of that. Okay, so here it makes sense, right? 263 nanoseconds is our average runtime, and we okay. I need to understand the runs thing. Um, where is it? Yeah, mean plus equals standard deviation of 7 runs, 100 loops each. This tells you that TimeIt ran your code 7 times and measured the execution of 100 loops within each run. It ran the code 7 times and measured the execution of 100 loops within each run. The reported average and standard deviation are calculated based on these multiple runs and loops. In summary, the result shows that your code typically takes 12.7 milliseconds to execute, with some variation around 718 microseconds in the execution times across different runs. Oh, this is interesting. So the standard deviation is basically an average of the variation, if I'm understanding this right. The standard deviation gives you an average value. It tells you on average how much each of the values are different from the mean, from the average. Okay, good to know. This is one of those things, like basic stats stuff. I feel like I have to come back every now and then and refresh my knowledge on it, which I don't think I'm gonna have to worry about that too much once I start getting deeper into data science. I'm already kind of getting there. Like I've been doing a bunch of this project that I took on, this little side project for which I'm looking to do the do the fake data and stuff. Um, Wait, give me a second. Yeah, this side project for which I'm looking to do the for which I want to create the fake data set so that I can show you the project on stream. That project, I've been doing a fair bit of work with pandas. Thanks to that project, I've been doing a fair bit of work with pandas, and I'm getting a lot, dude. I'm not even kidding. I'm getting a lot of experience with pandas thanks to that project and some other projects as well that I've worked on. Um, it's great. It's awesome. So like I'm looking forward to carrying this knowledge and experience into other data science stuff. We still need to get back to that fucking linear regression, dude. Like we looked at the theory portion of it and then just stopped. So like we need to get back to that. I have a couple of things to do before that, so I'm going to finish those things. I mean, kind of like, I mean, it's not like they're all urgent, but like I've started the faker thing, learning about the faker library, so I'm going to I want to do a video on that. I'm going to finish the video on that and also then finish creating the, you know, dummy version, the fake version of the original data set that I have. Once I've done that, um, then we can move on from the faker library. And yeah, I think at that point, hold on. Like I've because I jump topics so often, I have to like note down everything that I'm doing. So we need to get back into doing stuff with Hugging Faces Transformers library. I need to look into that as well. I've already kind of started using it, but like I still have there's still a bunch of there's still a bunch of stuff that I need to learn. Like I'm kind of comfortable with it already, but there's still a lot for me to learn. So I wanna get back into that, and I want to finish learning about linear regression. I want to do linear regression practically and mess around with it practically before we move on with that Kaggle course that we were doing. So yeah, I have yeah, you know what? Let me just add that as well. Um Let me add that to the list. Get back into Kaggle. Great. Awesome. Also, speaking of Hugging Face transformers, because the transformers library helps you, it makes it easier for you to use a bunch of different models. Like they add support for various models in there, and they make it easier for you to use those models. That reminded me, Facebook, Meta, they recently released a model called Sapiens. I want to show you guys this model. At some point in time, I want to look into this model. Dude, at some point in time, I want to be exploring models on stream. Like I want to make that a thing. Like dedicating certain streams to exploring certain models, certain open source models basically. Not I don't know why I said basically for that. There was nothing to, but I mean, I'm trying to clarify that, yeah, certain open source models. I want to look into open source models, but the ones that my system can run, because I'm going to be running them locally. I'm not going to be running them in the cloud. Um, okay, Sarah, that's great, cool. What was I going to look into? I was going to look into, yes, Meta Sapiens. So they made this thing, right? They made this open source model, which I want to try out, but I don't know if my system is gonna support it or if my system can handle it. I should say that. I don't know if my system can handle it. Um Back up. Let me just transition back. So this is the model. It's called Sapiens. Let me just read the quote unquote read the brochure. So, Sapiens offers a comprehensive suite for human centric vision tasks, example 2D pose, part segmentation, depth, normal, etc. Depth, I'm interested in looking at the depth and the 2D pose because I have use cases for both of them and I want to see how well it runs because they have, I think they have two or three different versions. Yeah, I think they have two or three different, like each of them has has a certain number of parameters, and the bigger the list is, or the more the parameters are, the heavier the model might be. So I'm gonna be going with the lighter version first, and then we can gradually see how much my system can handle. So this is sort of a demonstration. This is showing the pose. And wait, can I open this up separately? I think I can open this up. This should be a part of this repo. So I should be able to open this up. Actually, I can probably open up the raw version of this. Is it going to open up the raw version? I'm not sure. Oh God, my system is freezing. Okay, so it's not the raw version, which is fine. But it's still opening up the GIF. Let that open up. While that opens up, okay, well, it's here. So here you can see there's pose and then there's segmentation, which, dude, this is kind of interesting as well. Look at the way that it's segmenting all of this. Like imagine this kind of thing where you can, for example, like this shows you the hair. What if you wanted to, let's say, use this to remove the hair and replace it with something else, right? And then you have the entire head minus the hair, right? What if you wanted to replace the face with something else, or hands or clothes or whatever? That's just one of the use cases. And look at how cool this is. Normal. It's generating a normal map out of this. And then this is also something I'm interested in, which is a depth map. I have certain things that I can do with this. Hey Demkeys, do you have water with you? Yes, I do. I absolutely have water. Thanks for reminding me. I need to hydrate. Give me a second. Okay. So I have two use cases for it right now. One is the pose estimation, and the other is depth map generation. I might have some use case for the normal thing as well. Maybe I'll have to see. But yeah, okay. So the interesting thing with pose is that they have, I think, three or four different versions where one version gives you a certain number of points, a certain number of uh, I mean, I think they're calling them key points, but basically landmarks, like the positions, the positions of the body, right? Because like in terms of in terms of body tracking, there's different there's different points that are going to be tracked. So they have one model that tracks, let's say, a small number of points, another model that tracks more than that, another model that tracks even more than that, and then another one that tracks even more. So like each one gets more and more detailed, and I'm guessing it's going to be more computationally expensive as well. So I'm initially going to go with the smaller model first. Look at this. Dude, this is crazy. Like I'm excited to try this out. I want to see how much faster this is going to be, because so far in terms of body tracking, the only thing that I've tried is MediaPipe. There have been some other libraries, some other models. I haven't tried them though. I do want to try this out. I want to see how much better this can be, if at all. Where was it? So they had the task somewhere here. They okay. I hold on. So this was, I think, a couple of weeks back that the news had dropped, and fortunately, it seems like they're still working on it. Yes, yes, they're still working on it. They are actively working on it, and I'm so bigger avatar models is going to have more tracks. No, so okay. Let me open the thing up and I'll show you. So okay, let's say we're talking about pose estimation. That's basically body tracking, full body tracking. The idea here is, just so you have an understanding of what's going on. The idea here is the webcam is going to capture the webcam is going to take a video of you, right? It's capturing it in frames, and then you run those frames through this model, and the model is going to detect where various parts of your body are. So in terms of body tracking, it assigns, because you have to have a way to actually do the body tracking. Like, how is it going to present the body tracking information, right? So the way that it does this is it assigns different it assigns points to different parts of your body, and then those points are what get tracked. So when the model returns the data, when it returns the result, it's giving you those points, and then you can visualize those points in various ways. And when you apply it to, let's say, another 3D model, for example, you can then make it so your own body movement moves the model itself. So you basically have full body tracking right there. Now, to answer your question, what increases the number of points is which model you choose, because they have four different models available for body pose estimation. Let the page load. Okay, give it a second. It's taking some time. Actually, in the meantime, I need to go back and check the music because the music stopped. Oh God, my system is having a. Okay, all right. So there are. Oh yeah, flashbang. That happens sometimes. Okay, so it mentions here we provide four models of varying size. They have Sapiens 0.3 billion, 0.6 billion, 1 billion, and 2 billion. In general, performance improves with increasing. Really? Hold up. I got that wrong. So I thought that the more parameters that they have, the slower the model would run. But it's saying here in general, performance improves with increasing model size. Okay, so it mentioned here that for general in the wild so and so with only body keep on. Oh, you know what? Okay, hold up. So when I mentioned the model size earlier, I was also talking about, or when I mentioned different models earlier, I was also talking about this, or actually, I was mainly talking about this, where what they're calling key points is basically what MediaPipe refers to as landmarks. I'm assuming it's what MediaPipe refers to as landmarks, which is basically the points on your body that are used for tracking. So it's going to assign different points, and then it's going to be tracking those different points. So it has 2 points for each of your wrists, two for each of your elbows, and then for your shoulders, and for the head they have a couple, and then there's various things. So if you have like additionally, if you have like, I don't know, finger tracking and stuff like that, it assigns points for that as well. um Wait, I don't fully understand this. So are these individual tasks that you can assign and then use whichever model you want? Okay, so navigate to the script directory and launch the inference scripts from for your desired key point configuration. You have a question? What's up, Sarah? Okay, so there are four scripts, one for each of these configurations. Wait, navigate? No, there's three scripts, and there's three configurations. So these are three configurations. Okay, and then for each of these configurations, you can specify whichever model you want, or is it choosing which model it's going to be using? Define input for your image directory and output for results. Visualization and key points in JSON format are saved to output. Customize line thickness, radius, and so and so, so and so. Okay, all right. Wait, so what's the idea here? This thing writes it to a file? How much do I know about tracking? Tracking specifically in VR? Nothing. I know actually, very little, not nearly as much as somebody who actually has full body tracking, full body VR tracking. Now, in terms of doing other kinds of full body tracking without VR, that is, I know a little bit because I've used certain libraries to do full body tracking, and at one point in time, I did have like a little bit of support for my own VTubing app. I wanted to add hands to my VTuber avatar, but not arms, specifically only hands, so that you see how I have my avatar right there with the cube and the three spheres. I wanted to have like two orbs that represented my hands. So whenever I move my hands around, then the those orbs would move around as well. At some point, I'll probably get back into that as well. Though once, so okay, I'm gonna get back into that, but I'm gonna be creating my own tracking hardware for that. I'm not gonna be using one of these models for that, because creating my own tracking hardware, it's gonna give me better results in terms of tracking. Actually, another thing that I want to use the tracking for is for my VJing app. So I kind of want to develop the technology for that, for like multiple purposes. Wait, so what is this saying? Navigate to the script directory and launch the inference scripts for your desired keypoint configuration. Okay, let's take a look at the script. Dude, we were supposed to be doing like the what is it even called? Jupyter magic commands. We were supposed to be doing magic commands, but we are not doing magic commands. All right, so what were we looking at? Pose. Okay, under pose, there's a setup configuration thing. Okay, there's a requirements thing. All right, there's scripts. Okay, let's take a look at scripts. Demo local, optimize, train. Let's take a look at local. Key points. There you go. Okay, so these are the scripts that I need to launch. Let's open up keypoint17.sh. Because okay, it seems to me like the result gets written to a JSON file, and then we have to read from that JSON file. Um, I'm not sure how performance friendly that is. Like constantly writing to a file and then reading from somewhere else. Set your input and output directories. Okay. Model card. Oh, so you uncommented to choose which model you want to use. Okay. Right. Data set, model. Okay. Bounding box detector. Okay. Okay. Wait, is this like running multiple Python scripts? Oh, okay. I was like, okay, maybe they have like a library that you can that you're gonna or that they are gonna use, and they have a Python script which fully does all of this stuff, but it seems like they're using a shell script for it. Run the process on the GPUs, allowing multiple jobs per GPU. Okay, cool, cool. Why did they make this a shell script? Why was this not all done in Python? I I'm curious about that. Okay, okay. Oh, yeah, the music stopped. Dude, actually, you know what? It is getting a bit late for me. So, here's what I'm gonna do. Actually, let's go back here. Right. So, we are gonna be raiding into Little Witch Oz. Oz is cool people. Oz is a friend of mine. Um, she's currently doing she's currently doing stream overlay things. She's making a stream overlay for, well, her stream. Sarah, thank you very much for hanging out and chatting and stuff. I appreciate you being here. Anyone else who might have been lurking in the chat, thanks for hanging out. Appreciate you being here. I'm going to try and stream again tomorrow. At the very least, I'll try to do a mute stream. But yeah. I hope you guys have a nice day, and I will see you all next time. Peace.